Hi everyone, my name is Dean and you're listening to the MLOps podcast. As you probably know, machine learning in general and data science are two fields that are evolving all the time, and it's really hard to keep up to date. Specifically, the area of bringing machine learning into production or into the real world seems like it's very confusing. There's a lot going on and it's hard to make sense of all that's happening around you. But on the other hand, there are a lot of smart people that are doing great work in bringing their own projects into production. And we've had a chance to speak with a lot of these people, but it definitely seems like the information is not widespread enough and a lot of people don't know of best practices and how other teams work. So that's why we decided to start this podcast, where we'll be speaking with people who are working in various types of machine learning teams and hearing about how they are bringing their projects into production. I hope you find this interesting, and let's get started. Hi, everyone, and welcome to the MLOps podcast. My name is Dean, your host, and today I have with me Charlene Chambliss. Charlene holds a master's in statistics from CSU and a bachelor's in psychology from Stanford. She was a data analyst at Crunchbase, a data scientist at Curology, and a machine learning fellow at Sharpest Minds. She was then a senior software engineer at Primer AI, where she took part in building Primer Automate, an AutoML platform for NLP tasks. And she is now an incoming senior software engineer at Aquarium Learning, where she's building other amazing things. So welcome, Charlene. It's great to have you here.
Hi, great to be here.
So you are sort of an expert in the area of getting NLP systems into production. And I'm curious if you were always especially drawn to NLP as a field, or did you happen to find yourself working in it?
Well, I started out in data science more generally. I got interested because I saw kind of all of the cool ways that it was being used in sort of socially impactful ways. Different applications of ML, like remote sensing for deforestation and just other interesting things like that, civic data analysis to reduce traffic fatalities, all that kind of cool stuff. And so I was like, okay, how do I get deeper into ML after I sort of had my data science experience at Curology? And then I was thinking, about the different subfields, and I realized that I have kind of an affinity for language. I've always just really liked kind of analyzing the nuances of language, and I was a big reader as a kid and all that stuff. So it kind of seemed like a natural fit for that reason. And also because like I saw NLP as a little bit more welcoming for people from like slightly more unconventional backgrounds, I guess, like myself, because I majored in psychology and not, computer science or electrical engineering or something, which tends to be more common in kind of general ML or the other subfields. And so I noticed that people in NLP, like a lot of them had pretty diverse backgrounds, but had still made really interesting contributions. And so that was kind of a draw to me for sure.
Interesting. Do you think that that's sort of a people thing, or the specifics of NLP make it more amenable to the varied background? Like to sort of the most complex models that we've built, right, so far have been NLP models, or arguably NLP models. Like maybe people don't agree with this, but you couldn't say that NLP is a less complex area, and so you might say like maybe it's less complex, so people come into it. So I'm curious, like, what are your thoughts? Like, why is it more diverse compared to other areas of machine learning?
Oh, that's a really interesting question. I think it's a combination of what you said. So one thing is kind of the people, like the kinds of people who tend to be interested in doing things with language, just come from all sorts of different backgrounds. They might come from like a literature background or a linguistics background or in like a language major background or something like that. And then they kind of moved into NLP, like from that academic sort of approach. Sorry, I'm losing my train of thought a little bit.
No, it makes sense. I feel like I've met a few people that have sort of studied linguistics, and I don't know why. This might be just the random group of people that I've met there, but I feel like people that study linguistics are some of the most excited, enthusiastic people that I've met. So maybe that means that it's like it's a draw. And I also think that language has something about it which makes it kind of unique. It's sort of what makes us unique. So maybe that's sort of part of the draw. It's like a more elementary part of being human. So it makes sense that AI is sort of has stronger foundations there, but also that it's a draw for a lot of people because it's very human to think about language.
Yeah, that's a great point. And I think one more point maybe is just like some of the details of the ML. So like for one thing, you know, computer vision models, you have to understand a lot about kind of convolutions and Fourier transforms and like stuff that you would kind of only have been exposed to if you had sort of a physics background. And so like that can be a little bit, I don't know, I don't want to say like intimidating, but you know, if it's basically mainly just matrix multiplication that you have to think about, then that simplifies things a little bit. Not to mention, you know, with NLP, we have Hugging Face, which has given us this beautiful, like very high level abstract interface that you can use in order to build these models, which I think there's still a little bit more like PyTorch fiddling and stuff that you have to do for computer vision.
Interesting. So just because this is like this is a personal thing, but Fourier transforms, I like they get a bad rap. I guess they are like objectively more complicated than other things that happen in the math world that are related to, you know, meaningful applicative things in the real world. But I do want to recommend, just if anyone's listening or watching and wants to better understand it, I think the YouTube channel 3 Blue 1 Brown has a great video on Fourier transforms. It's just something that I personally remember. So I did study physics, and I remember the second year basically going into the first class, and I didn't study it in my first year as opposed to many of the people that I studied with, and it was kind of a culture shock. But in the end, I mean, it's fun to understand it. And I think that there are really good videos today, so I recommend that. But I guess we're here to talk about ML and MLOps. So I'm curious, like, obviously getting models to production has its challenges no matter what type of model you work on. But one of the things that surprised me when I was speaking to you the first time was that sort of there are a lot of unique things about getting machine learning models into production when we're talking about NLP systems. And this is not necessarily related just to the model, but also to working with the data. So I'm curious, like, what do you see as the main differences and constraints between working with NLP and any other ML subfield?
Yeah, absolutely. I think other ML subfields have had kind of a lot of success solving problems with sort of smaller to moderate sized models that are somewhat more easily deployable. Whereas like all of the best models for NLP nowadays, like Roberta, GPT-3 and all of its descendants, basically any large transformer variant, they're massive. You know, they can be like, you know, a gigabyte of space in your memory, like on your virtual machine. And so that can be pretty tough to work with just operationally. It requires like very powerful GPUs in order to like run inference in a reasonable amount of time. And like just the compute costs of running these kinds of models can be very high and really eat into your margins, like if you're a business trying to actually make use of these things. And it gets even worse if you're like the type of business that your product is only valuable if every customer gets to have their own custom model. And then you have to actually like manage the costs of like deploying all those models for inference. So that can be kind of rough. But people right now are looking into different ways to shrink models, such as like pruning, distillation, quantization, running examples through only some layers. One thing we've used is something called inference triage at Primer, where you kind of use a smaller model to gatekeep like your larger model, so it kind of handles the easy examples, and then if something is a more difficult example, it passes it on to the big model. That can save you a lot of time and cost. The second thing that makes MLOps challenging for NLP is just it's really hard to do data augmentation in a way that's like actually semantically valid and automated, because like language is discrete and contextual. So if you change like a given word in a sentence to try and make like a second example that's slightly different, let's say like you have, I love this person, and then you have, I adore this person. Like those two things are synonyms, but the connotation of each word is kind of different enough that they're like not quite the same. Whereas with something like computer vision, you know, if you just like cut part of the image off or something like that, it's still more or less the same image, just with that part missing. So it's a little bit different in that sense. Another thing is that a lot of tasks are actually really hard to automate or really hard to evaluate without having humans in the loop. And like, those are also the tasks that are like the most useful sort of applications of NLP, like translations and summarization, particularly anything that is taking a sequence and going to another generated sequence. So like, there's no such thing as kind of an automated fact-checking algorithm. So if you have a summarization model and it's outputting like completely made up facts that were not in the original article, like you have to have a human read that and notice that, because like, you know, if you're using Rouge score or like one of the other traditional metrics, like it's just going to measure token overlap. Like it has no sense of like whether it's actually true and useful to a human. So those are kind of the main things.
There are so many interesting things that you said there. I have a few sort of follow-up questions. Just like today, I was reading over a Facebook discussion where someone was saying like, so I'm, for maybe some of the people don't know, like I'm in Israel. We speak Hebrew, and so someone is trying to train a large language model for Hebrew. And apparently there's not that many languages in the world that have large language models actually trained for them from scratch. So I'm not talking about like fine tuning and stuff like that. So he was asking for advice from people that have had experience training large ML models. And basically the overwhelming advice was everything you know from smaller models doesn't really apply to larger models. It's like a different class of problem. And some of those things are the things that you just described now. I think that the first thing that you said that was interesting to me is like the model triage. So, I mean, I feel like the idea is very intuitive. I'm very curious on how the sort of application actually looks. I'm guessing that there are no frameworks for that, right? Like, is this something that you had to custom tailor for your use case? So does that work like by the smaller model predicts and also provides a confidence interval, and then depending on that, it either goes to the larger model or not? Does that make sense?
Yeah, so at Primer, any kind of custom pipeline stuff like that we would have to build, they have sort of their own ML platform to handle that. And so we kind of just compose it out of pieces. So like we have the deep learning library, and then the deep learning library has the individual models. And then, you know, kind of on top of that, you have a pipeline orchestrator that's kind of running the documents through the different models.
Okay. And then for augmentation, like when I first heard about the sort of the challenges in data augmentation for NLP from you, the thing that sort of made sense to me is computer vision. Like most of the applications that people know are handling sort of natural images. And they're like, if you have a tree with a bird on it, and then you remove the bird, the tree still makes sense. But in language, there's this whole thing, like everyone who speaks more than one language and sort of has another language, which is maybe sort of native, they might look at some sentence that someone else wrote, and it just doesn't make sense, but you don't know to pinpoint why it doesn't make sense. Like something grammatical or I don't know, whatever it is, it just doesn't click. And you know to point that out, but you don't know exactly to explain why. And I feel like it's much more intuitive to people in sort of the context of images or videos than it is in the context of language. And so since we can't define the problem properly, it's hard to pass that on to a computer in a sense. And obviously deep learning is trying to take over for that issue by sort of letting the computer understand for itself. But when you need to define the data, then that task is still on you to a certain extent. But yeah, I guess when you do work on data augmentations in NLP, like, is there a way or some recommendations you have for being able to actually understand what's going on, make sense of whether augmentations make sense, especially if you can't, if it's like unfeasible to just look at everything, right? Like ideally you just go over the examples and make sure, but if you can't do that, is there some rule of thumb or technique to understand what's going on?
Yeah, totally. So first I want to mention that there are some frameworks nowadays that are making data augmentation for NLP a little bit easier. So they'll have a bunch of different rules that you can use and customize to like generate new examples from a given example. And then, you still have to look through those manually to make sure that like, they're not too weird or crazy or different. But it helps with the process a lot, I think. And then the second thing is, if you don't want to go that route, what you can actually do is kind of just expand the space around your current examples and just get more documents that look somewhat like, the documents that your model found challenging, for example. And so you can kind of project your documents into sort of the embedding space generated by that particular document vector. And then you can kind of do a nearest neighbor search for maybe the documents around it, and then you can sample those. This, of course, requires, having access to a very large unlabeled data set that happens to be the same distribution as whatever documents your model is not doing well on. So I guess that's not necessarily a given.
and a good embedding function.
Yeah, exactly. Oftentimes people will just use, the output from the hidden layers of the model, for example.
Yeah. And I guess there's also like now all the standard embedding models that are accessible, like Word2Vec and things like that. But yeah, I guess data somehow always becomes the issue, right? So I know that sort of data labeling is part of the platform that you're working on. Can you share like what the role that has within the sort of broader workflow and how important that is?
Yeah, absolutely. So there's been kind of a paradigm shift in NLP over the last few years. Where initially, in order to make NLP models work, you were training like an RNN or a CNN, and you needed like tens of thousands of examples of like the specific task that you were doing. Nowadays, we have these giant transformer models, and they've been pre-trained on all of this internet text. And so they already like kind of have enough context to like roughly understand like the rules of language and kind of how things in a sentence tend to relate to each other and stuff like that. And so what you can do nowadays is you only need like, maybe in the range of a few thousand examples just to get to like, 80 to 85 F1 score. And so you can get like a pretty good model with like relatively few examples. But the thing that's different is that like, instead of creating kind of a bunch of like potentially noisy sort of unsupervised data or semi-supervised data, like you could when, you had 100,000 examples. Now you need to be a lot more careful about kind of which examples you give the model, because it's so smart that it can be swayed very easily by wrong data. And so extra attention needs to be paid to kind of the data labeling process. And there needs to be kind of a lot more QA. There needs to be much stronger task definitions. Everyone needs to be exactly on the same page about how to handle certain edge cases. And so that becomes very important in kind of new NLP land.
Yeah, I mean, I think that it's interesting. The same discussion that I'm describing now about training large language models, the first thing that was mentioned about the data is that counterintuitively, you want to go quality over quantity, because models can learn so many bad things. The larger they get, then you have to make sure that you're throwing out the bad examples. Otherwise, you can spend a lot of money and time on training a big model and then having it learn a lot of noise, which is useless. So I feel like this is sort of an all roads lead to Rome sort of thing, where no matter which avenue of machine learning you go down, you get to the point where like data quality matters. And I remember like the first time you and I spoke, I was really excited about the fact that you were really excited about data quality. So I'm curious, like, why you are excited about it and how do you get more people excited about it? Because in a lot of cases, you speak to data scientists and like, oh, data quality is the thing I'm waiting for someone else to take away from me. So yeah, how do you think about that?
I think that caring about data quality is actually really empowering, because personally in my ML career, like what I've noticed is that getting more data and getting better data for your model is actually much higher impact on model performance than like any amount of hyperparameter tuning or like architecture tweaking or any sort of more pure ML staying in the code sort of fanciness. Like I would rather have 1,000 more labeled examples than a comprehensive hyperparameter search any day of the week. Like the 1,000 examples could give me another like 10 F1, whereas hyperparameters are going to give me maybe like 2 or 3 F1 max. And I think that that's exciting, not just for like your potential impact as an ML engineer, but it's also exciting from the business perspective because like you don't need to have kind of an army of research data scientists and ML engineers just to get to like a pretty good model in NLP. Like all you need is the kind of rigor and patience to create a well-defined task and to reinforce and adjust those definitions carefully as the new edge cases emerge. The NLP tooling is just so good nowadays that NLP models are within reach for anyone with good critical thinking skills, really.
That's a strong snippet from this episode. I mean, I tend to agree, and I think that that's for good or for bad. Like if your dream is to do hyperparameter tuning and just playing around with architecture, then I mean, I think that there are still cases where that makes sense, but I feel like the majority of cases you need to start with working on data. So
yeah, for sure. Like if you do want to do that, you know, go work for Google or Facebook or OpenAI. But most places are not going to need that for the kind of tasks that they're tackling.
Yeah, and I think that sort of makes sense, right? Like they're in most companies, you're trying to build some product, and machine learning should help that product be built, but it's not. It is not a sort of an end in and of itself. And then to get to the end of having a good product that is useful to people, usually you need good data. I feel like you sort of, with your experience, like what are your tips and best practices on how to do data labeling and NLP and like just in general better?
Yeah, absolutely. So I spent a long time kind of early on at Primer managing sort of the data labeling process for the applied research team. And there's a specific kind of a step-by-step process that we've seen work really well, which is first, the engineer building the model should label 50 to 100 examples by themselves by hand, because that'll give you a firsthand look at kind of what's actually in the data, sort of what types of distinctions that you'll need to make between different types of examples. It'll give you a sense of maybe the different classes that exist. For example, if you have a classification task and like whether or not you've forgotten any classes in sort of your initial conceptualization of the task and need to add them in later. Then you go in and you write down some solid definitions of those classes and concepts that you're trying to get the model to identify. You should include instructions on how to handle like specific edge cases. Ideally, you know, you want to have like kind of types of edge cases as opposed to like very specific edge cases like, always tag University of Arizona as a location or something like that. You should say instead, you know, tag universities as locations, because that's kind of a more useful general rule. Then as you have kind of better instructions, you can iteratively get larger batches of documents labeled by external partners or by other folks within the company who are willing to help with labeling. And let's say like 100 or 200 at a time. This gives you the opportunity to spot and correct any kind of misconceptions that labelers have about the task or that you have about the task, and to add any kind of necessary clarifications to the instructions that have become apparent once you've been exposed to like more of the data distribution. And so kind of iteratively, like I said, as the labeling team understands the task better, you can actually increase the batch size. So you don't have to be doing small batches of 100 or so. Like when the labelers actually really get the task, like you can give them 1,000 and then they'll come back like just as high quality as before.
Yeah, I like that. That's so practical. I feel like this is, it just makes sense. I feel like the next sort of logical step is, once you do that, you want to start automating stuff, right? And so like, how do you know, or how do you automate the process in general? And then when does that make sense and when does it not make sense? Like, who shouldn't be automating the labeling process?
Yes. So there, you definitely want to tread carefully with automation in this the data labeling and curation process. So like things that can be automated, sampling new documents to be labeled based on some pre-specified criteria, you know, similarity between document vectors for like documents that your model got wrong previously or that it found challenging in the last training run. You can automate applying pre-labels to your documents in like, I guess this is kind of a semi-supervised way, but basically you take your existing model and then you apply them to the new documents that you want to get labeled. And then you just give the labelers the labels for those documents. You don't want to do this too early on though, because it could actually bias the labelers to like, you know, include your model's mistakes in the data and not correct those because they're like inclined to listen to the model. You want to do this when your model is already pretty good, ideally, and you're kind of going that last mile to make it amazing. You can also automate gathering feedback from end users. This is particularly relevant for people who make kind of consumer-facing products, but it is also relevant for B2B products because you can build kind of a feedback mechanism straight into the product. And then you can ingest those results to look through later in terms of what users found kind of incongruous as like an output of the model. They're like, oh, this isn't right. You should give them the opportunity to tell you that, even if you're not going to use it right away. Things that you can't automate would be doing the actual error analysis and recognizing those patterns in the examples that your model got wrong. Like this is all still entirely manual. And one of the things that we want to make much, much easier at Aquarium. So like being able to kind of explore your test data set and figuring out like, what are the commonalities between these examples that my model got wrong? That's still a very kind of cognitive process that you have to do because, I don't know, there just isn't really an automated way of doing that right now. And then lastly, getting a sense of whether or not the model is actually good enough to what you need to use it for. Usually that requires kind of input from some stakeholders. So you can't really automate like, oh, you know, my model has 99% accuracy, therefore it's good enough. Like that's not guaranteed. It depends on the task. It depends on, you know, what's in that last 1% of accuracy. You know, if your model has 100% precision and 0% recall, that's not very useful. And so, yeah, you definitely need to kind of have human eyes on the model's outputs rather than just relying on the metrics.
Yeah, that makes sense. I feel like the things that you said we can't automate also really relate to the whole realm of monitoring, right? Because you need to sort of anchor the results of your model in reality, and that's usually still hard to automate. And you just need a person to look at these things. Like again, part of the idea here is a metric is not probably going to ever be good enough, especially for complex tasks. You're still going to want to do predictions and then qualitatively assess those predictions to a certain extent. And then the second part, which is like the decision to maybe deploy a model or to switch the main model with the new model or something like that, that still seems to me as well, like speaking to companies. It's something people would want to automate, but I haven't heard of anyone successfully doing that. Maybe Google with ad models and things like that, but it's relatively not pervasive, and most of the companies still do this manually.
Yeah, like there are ways of kind of monitoring whether your model has drifted too much from like the last version to the new version. Like you can analyze the like distribution of classes of your model's predictions. You can, I lost my train of thought again.
Yeah, no.
But yeah, there are things you can do. People have made like automated tests for like the easier examples. So like examples that your model should definitely get right, and then you like run the model through those before you deploy it. And sometimes people catch things like, oh, you know, we had a bug in the training code, and now the model is like acting completely crazy. So you can catch certain pathological examples like that, but like sometimes the differences can be more subtle.
Yeah, there are a few good packages for these things. I think like Great Expectations and then Deep Checks more recently, I think are doing a great job on this front. And it's very necessary. Like it's the same old issue from software development where you won't have bugs if you don't write any tests, right?
Yeah.
So like, yeah, definitely unit testing for data and models is a great idea. It's usually for the basic mistakes, it's almost effortless to do it. And then it has the potential to save you so much grief. So it's definitely very worth it. I had the chance to speak, and it does seem like part of what you're doing at Aquarium relates to this. It's a bunch of people who are working on ways to help you as a user understand the examples that your model is having a hard time on, or to maybe anticipate examples that your model is going to have a hard time in production. I feel like that's still very early, but I'm excited about that. I think that there is potential to improve that experience. And then that also ties back into labeling, because ideally you'd want to automate that entire process, find those hard samples, label them or relabel them, then push them back into the training set and improve your model. So I think that there's a lot of good work to be done there. And there are a lot of things that I guess will stay manual, and that's okay. Like you still probably want a human in the loop just to make sure that the model is doing something that is actually useful to humans. I guess we'll be in a, like, I try to avoid the robot takeover stuff, but I guess we'll be in a very bad position if we don't need humans anymore because robots decide what's good for them and we don't matter. So yeah, but
yeah, I prefer not to think about that. That's pretty far in the future.
yeah. I guess another question that comes up here is, so I think a lot of the things that you said relate to the fact that there's a lot in common between like good data labeling or good data treatment and sort of product management, like treating your data as if it was a product that you need to work on. There's the whole MVP stage. You do the things yourself, you do things manually before you try to set out rules and then automate that and then extend it to other people within your team and things like that. One important thing in like product management, or maybe this is true for entrepreneurship, but you want to shorten the iteration cycle, be able to learn quickly and then improve the product that you're working on. So how long is an iteration cycle for data labeling? Like how fast could it work if you have done a good job of automating things?
Yeah, and that's a great observation between kind of this iteration cycle and product management. Data should definitely be kind of a first-class object in terms of your ML project management. In terms of how long an iteration cycle is, hopefully a few days or less if you have a really tight communication loop with your labeling team. Like, maybe you have them in a connected Slack channel. And so if the labelers have questions while they're labeling, they can just ask you and you can tell them if you're online, of course. But yeah, like it gets shorter over time. So of course, like you said, in the MVP stage, when you're kind of really trying to hammer out like the right definitions of everything and catch kind of, the 80% of the 20% of the edge cases that are going to handle 80% of the examples, then those cycles are a little bit longer, but kind of once your labeling team starts to understand the task really well, they can get the documents back to you quickly. QA can be done quickly. And so, yeah, hopefully a few days or less, depending on the batch size.
Fair enough. I think that's a good rule of thumb or order of magnitude. If you're thinking about building out a labeling function within your organization or working with people, I think that this is either a good place to aim for, or it will give you sort of a range of what you're looking at when you're iterating on data.
Yeah, and I should caveat, like, that's for NLP. I can't speak to kind of the vision space where, you know, the data sets tend to be larger. But for NLP documents, you know, you can generally get like a good improvement with your model with another like 300 to 500 documents.
Interesting. I guess I have to have a discussion with someone working on the computer vision space to compare notes, but I think that this is still probably a good order of magnitude. Yeah, I guess you also have transfer learning with computer vision. You have potentially shorter iteration cycles as well. But it's interesting. So in the end, one of the challenges here is most of the NLP tasks are not labeling NLP papers. And so that means that you have stakeholders that maybe are domain experts, but they're not sort of from the area of expertise that you are an expert in. And so there is this question of how do you make this accessible or optimized for shortening the iteration cycle and things like that. So I'd be curious to hear your thoughts about that as well.
Yeah, so I've worked with a lot of outsourced teams, a lot of labeling teams, and I've personally labeled a lot of data in various labeling tools. And so when you're kind of designing this process of labeling, you should help your user do the correct thing. So like said another way, make it easy for users not to do the wrong thing. So for example, you know, if you have kind of your own in-house labeling platform, or you're trying to select a labeling tool, look for something like, you know, snapping to the span if your task is to highlight spans, instead of allowing, you know, kind of white space on the sides or anything like that. You can do things like highlighting possible errors, like if some punctuation has been included in the span, you can call that out visually. Keyboard shortcuts and navigation makes things so much faster. You can also use information about the task to prevent doing the wrong thing. For example, for relationship extraction, you have kind of two entities that can be related to each other. And often those entities will be like specific types of entities. So let's say like organizations collaborating with other organizations on a joint venture or something like that. So like, as you're designing highlighting for that, like if someone has an organization selected and the relationship they're going to make is the collaborated with organization, you can kind of make the other non-organization entities less prominent and kind of make the organization entities more visible. And then it's easier kind of just quickly to scan the page and find the one that you want to connect to. You can also even just completely prevent making relationships between like the wrong entity types, because that's just something that you have to go back and fix in your data later. So you might as well just prevent it at the labeling stage. And then lastly, you should definitely try to minimize kind of the number and complexity of actions that you need to label. So like a big pet peeve of mine is actions that require click and drag, because some folks working on annotation teams are using a touchpad to label, you know, like they're working on a laptop, they're not working at a desktop computer. And this is a lot less accessible for them, not to mention it just takes longer. So if you can do, you know, click here and then click there for kind of the destination, that can be a lot better than clicking and dragging.
That's really nice. I like that as well. I feel like there's design plays such an important role in everything that we do, right? Whether it's software design or interface design and all of those things, they make a huge difference in how things are done and how we can make them better for the people that are doing the work, but also for the results. Like usually this translates into better labels, right? And so that is, I like that. There's a lot of great tips here. If we have listeners from any of the labeling tools, then there are a lot of great ideas to implement here. Okay, so one of the main topics that we sort of like to discuss in this podcast is deploying machine learning and machine learning models to production. I think that we discussed a bunch of sort of more complex setups for deployment. So I'm curious, how do you deploy complex NLP pipelines, especially when you have a combination of models and data processing steps into production?
Yeah, great question. So usually models are deployed in a containerized fashion, as many folks will probably be familiar with. So you'll usually have one model or model type per container. But sometimes, like you said, you'll need to chain two models together. For example, for relationship extraction, first you have to actually extract the named entities from the document using a named entity recognition model. And then you would also want to extract relationships between those entities with usually a relationship classification model that takes entity pairs and then tells you whether or not they're related in that particular way. And so for these kinds of model stacks or cascades or pipelines or whatever you like to call them, it can be ideal to kind of deploy all the models in one container if they'll actually fit. Because then if you can fit all the models in GPU with enough memory space left to perform inference reasonably quickly, that allows you to kind of minimize latency. And this is particularly important if you have something that's kind of a real-time application as opposed to like a long-running processing pipeline. It also allows you to create kind of a more consistent interface between kind of how you're sending and receiving data to the model servers. Because you don't need to be like sending some servers structured inference data from a different model. You can just send a document and then get back the results. And so that kind of can make it a lot easier to interact with those deployed models for the services that do interact with them. Yeah, that's about it, I would say.
So that makes a lot of sense. I guess one sort of follow-up question to that is, if you're deploying these systems into production, do you, like the interfaces that you just described, do you enforce them, let's say culturally, or is that something that you build into the system somehow to make it so that you have these standardized interfaces and things like that? And also, what happens if you can't fit multiple models in one container? Do you just give up on the standardized interface, or is there any other creative solution?
Yeah, for your last question, I'm not sure that there are any creative ways around that. You'll just end up having to do the non-ideal thing, and then maybe from the outside make it look as if you're just sending in the document and getting the results back. In terms of how you can kind of enforce that across the organization, I mean, it probably depends on how big the organization is. If you're like a relatively small company with like only a few hundred people, and you have like a single platform team managing all the ML deployments, they can usually kind of standardize that interface and everyone just has to use that. But once you have many different teams kind of proliferating their own ML solutions, that can be a little bit more difficult to standardize.
So yeah, I agree. I think that one of the things, I guess, I've also had the chance to speak with larger organizations that they also try to standardize it culturally. Like, I mean, when I say culturally, I just mean someone defines an interface or a set of interfaces, and your model or transformation has to comply with one of those interfaces. Otherwise, it just won't get deployed for a bunch of different reasons. Like one of those reasons could be that it's harder to work with, but a more reasonable explanation is just you want like an optimized, you want to optimize performance. And if you have random interfaces, you might not be able to do that. The simplest example for this is the whole Pandas, Spark, compatible APIs and stuff like that. Usually when you get to deploying at large scale, you sort of have to trade off certain actions or functions in these frameworks because they're not efficient and there's no good way to make them efficient. And so the limitation is like, you can't use this set of functions if you want to be deployed. Otherwise, latency will be too high and we can't afford that.
Right.
And then just to offer one idea on how you can still standardize, like even if you do need to chain models, one way that I think we've seen this in one of the companies that we spoke with is you can have one input interface, which receives that document, and one output interface, which outputs whatever it is you want to output. And then from those sort of gateways, you have a standardized model interface, and that gets like some standardized input, gets out some standardized output, and then you can move that along between the different models. So usually the scientist or whoever it is that's deploying their specific model within this larger system, they don't need to worry about the first input and the last output. They just need to worry about like having a compliant interface for the prediction part. It's not always possible, right? Because you can say like, well, what if the dimensions of my tensor are different per model and things like that? But you can relatively easily generalize that part, because it's just like different dimensions for the same type. As opposed to, like you say, if the user uploads a document and obviously you're not working with raw documents in your models, then you need to have some solution for getting that into the language of the model. So yeah, that makes a lot of sense. And I think that there's a lot of interesting things that are maybe too specific to get into here, but you covered a lot of them, and that's really awesome. I want to end with a few sort of higher level questions that I like to ask all of my guests. So the first is like, what are you personally excited about? Or like, what are the strongest, most exciting trends in ML and MLOps?
Yeah, great question. There are so many great things going on in ML right now. So one trend that I'm seeing, of course, as someone who has worked on one of these, is low code and no code tools. It's becoming easier and easier as a business user to actually have access to these very powerful models and model deployments. And you don't have to have 2 years of experience in statistics and writing Python in order to build and deploy a model that could be useful for your team. I'm also noticing that tooling for technical users is becoming kind of higher level. So something like Aquarium is a great example of this. It's an interface that you can actually use to explore your data and to easily kind of create issues around certain patterns that you're seeing. Whereas previously when I was trying to do error analysis on my models, I was manually printing the documents and then, what kind of mistake the model made, and then just scrolling through them in my Jupyter notebook, which, obviously requires me to switch between writing code and then thinking. And then there's just kind of a lot of cognitive overhead with that. And it makes things slower. So having these higher level interfaces is going to help really streamline this iteration step for technical users, I think. The ML tooling space is also growing generally. So I'm noticing just a huge proliferation of ML tools. And many of these pain points that I described about, for example, the manualness of data set exploration, data augmentation, error analysis, these things will eventually be kind of a thing of the past in terms of how tedious they are and just how much manual work they require. There are also more platforms that are trying to abstract away some of the DevOps parts of MLOps, like model deployments. I think Verda is a good example of this by making deploying, managing, and monitoring your models significantly easier. The data infrastructure space is consolidating also. That's another cool trend that I'm seeing. And this has the benefit of allowing ML engineers to spend a lot less time thinking about the data engineering and the pipelining aspects of getting data into their models and out of their models, because the data storage and processing providers are starting to also provide kind of adjacent integrated services to make their products stickier. So Snowflake's acquisition of Streamlit is a good example of this.
Yeah. So that last one is, I find that very interesting. And to me, it was a bit counterintuitive in the beginning, but it makes sense in hindsight. I think that part of this, when this is sort of maybe a thread that connects all of the points that you said, but especially the ones related to infrastructure and tooling, is that up until relatively recently, it felt like people are not really sure what the proper components of a workflow in machine learning are. And now that it seems we're still not there. I still feel like there's work to be done on sort of making the ML realm less fuzzy. But I think we're heading towards that direction. And the main advantage for users in that case is if you know the boundaries of a certain task, you can do it much better. And so the tools are going to be better, as you say, and that's why like everyone's going to benefit, right? You're going to have less cognitive overload in deciding what tools you want, because it will be clearer what value they're going to give you as part of your workflow. And then they're also going to be better at what they do, because they won't have to say that they do everything in order for you to perceive them as valuable. So I think I agree with you. Like, I think it's really exciting. There are a lot of interesting things happening. If you are one of those people that feel like everything is confusing and you can't make sense of anything going on in the field, I think that the next few years are going to change that, and things are going to be clearer and more well-defined. So hold on, it'll be, the good part is coming. The next question I have is, this is something that comes up with every person I speak to in the field, which is, as you say, so much is happening. How do you keep up to date with things? Like how, maybe what channels do you follow, or what things do you do on a regular basis to stay up to date?
Yeah, totally. So among friends and coworkers, I'm a little bit notorious for being an information junkie. So hopefully I can be helpful with this. Particularly for NLP, some of the sources that I follow are NLP Highlights. That's a really great podcast. Researchers will often go on there to discuss kind of their interesting new findings. They usually discuss it in more accessible terms than the actual paper will. And so, especially if you plan on reading the paper later, having that initial higher level introduction to it can be really helpful. It's been on hiatus for the last few months, but the archive is definitely well worth visiting, because there are some really good ones on there. Sebastian Reuter has an amazing blog and newsletter. Like, he's so good. Yes. It's an absolute treasure trove. He doesn't update as frequently now, but the updates when they do come out are still very juicy, and they make up for the time that you waited. Software Engineering Daily is also really, really good. Great podcast for keeping tabs on what's going on in software generally. So keeping track of trends in, containerization and DevOps. And in addition to ML, they specifically have like an ML channel that you can subscribe to if you don't care that much about the other stuff. There's also Twiml AI, another podcast that I've been fortunate to guest on, which is awesome and covers like tons of different areas of ML, not just NLP. Talk Python to me is great for general Python stuff, and they often will have ML specific guests or data science specific guests. And then I also have a couple of articles that I can send along for you to put in the show notes or something. Taming the Tail by A16Z is a really great read on the challenges of running an ML first business, particularly how it compares to running like a more standard SaaS business, and how you can think more clearly about like what you can expect for your margins and where you can expect most of your costs to be and stuff like that. And then every year I also check out the State of AI report, which I thought about particularly when you were talking about, if you're someone who's looking on and seeing like this massive proliferation of things.
Yeah.
So there's the kind of an infamous image from those reports where it'll just be a big square and it'll have multiple different squares of like different companies in different areas of ML. And there are more and more companies every year. But it's a great way to kind of to help make sense of kind of what are the different areas right now, what changes are we observing? And that's the way that's part of how I can notice like some of these higher level trends that are going on, is just hearing about like what's going on with other companies, because otherwise I'm pretty like zoomed in on, what I'm working on and what's directly adjacent to what I'm doing. And then I would also suggest following any researchers that you like on Twitter, any research groups, stuff like that, so that you can hear about it when a splashy new paper comes out or something.
Those are a lot of great recommendations. The ones that I do know, I second them. Like Sebastian Reuter is awesome. I really love his newsletter. I feel like every time I see another, I think the technical term is Loom Escape, but I might be wrong. The one with all of the logos. It sort of is exciting and bothers me at the same time. There are so many, it's just ridiculous. And yeah, it like depends on which list you want to believe, but it's like somewhere between 300 and like 5,000 tools. So yeah, I understand the frustration of people when they see those. So I guess you gave a bunch of recommendations that are machine learning related, but I'll ask if you have any other recommendations that are maybe not machine learning related or not, not related to your job at all, whether it's Netflix shows or whatever you want to recommend.
Oh, that's interesting. I do have kind of just a general sort of mindset recommendation that I can give, which is, if you're listening to this and you're new to the space, whether that's like ML or NLP or anything else, if this seems overwhelming, like we kind of just mentioned, you would be amazed like how much you can just learn by osmosis by listening to things like this. I actually attribute a lot of my own success in transitioning into data science from a less technical background to the fact that I just consumed tons of data science and NLP related content. And eventually, you learn the vocab, you learn kind of what the main problems in the space are, you learn how people address certain issues. You learn about like which tools and frameworks are actually the ones that people use instead of just the ones that exist out there in theory and that you might have to learn someday. And a lot of other practical details that'll help you in kind of your day-to-day journey just by listening to practitioners talk about it. You can also do like informational interviews and things like that. Like I did also read, textbooks and everything, but to get a picture of what things actually look like on the day-to-day, the podcasts, the conference talks, and other kinds of conversations are just super helpful. Because without these, you can really get the impression that you need to know every possible thing before you can be even remotely competent in this field, but that's not the case at all. Like there are so many of us who are like very expert in one particular area, but if you asked us to do something in some other area, we'd be like, give me a week to go learn it. And so as long as you're scrappy and you keep a beginner's mind, like you can learn whatever you need to learn to make really cool stuff.
Yeah, I also think that that's an awesome point. And I think in general, the skill, if you will, that you have to possess is just wanting to learn, right? Like there's so many things you can do if you just want to learn. And I think part of that is being genuinely excited about a field. It's harder if you're just, forcing yourself to do it because you heard that software developers make a lot of money if they work at Google, then that you're going to have a harder time. It's not impossible, and some people are talented enough, but I think if you're actually enthusiastic, then becoming an information junkie, as you called it earlier, makes a lot of sense. I'll add one tip in that vein, which I think is true regardless of what thing you want to do. Like it doesn't have to be machine learning development or anything like that. And now with COVID, we've had a bunch of time where all the meetups and events were virtual. I'm still advising everyone to keep safe and not get COVID. It's still not fun. But if you have an opportunity to go to a meetup that has sort of in-person meeting, then speaking to people, like the talks are important, but if you speak to other people that are either in your position or ahead of you a few years, and you can learn from their experience and build those relationships, that is super important, especially if you don't come with the background that is as you say, like good computer science or technical or something like that. Building relationships is super important no matter what you do, and the ability to find people that have sort of gone a few miles in your future shoes, and then learning from their experiences is really invaluable. So you should do that. If you can't go in person, go to the virtual meetups. Sometimes they do have mingling in the beginning, even though on Zoom it's not as fun and there's no pizza unless you order it in advance. But yeah, you should totally do that. Oh, and if you go to the meetups, don't only eat, also speak to people. That's also important. This is speaking from experience. Yeah. So
I do have one more tip that I can give around, it's kind of a meta advice around learning generally. So learning how to learn is actually a skill, and one that you can improve at actually very effectively. There are certain techniques that you can use, like spaced repetition, kind of forcing yourself to recall answers instead of just reading your notes and saying like, oh yeah, I remember that. And two people who I can recommend that are like very good at teaching this material are Scott Young. He's kind of the blogger king of learning how to learn. He like basically did a 4-year MIT CS degree in a very, very short amount of time just from home. And Cal Newport is also really, really good to listen to in this area. So I would check out their stuff. Ultra Learning by Scott Young is a really good book that kind of encapsulates like most of his recommendations. And then Michael Nielsen also has a really good blog on how to use spaced repetition using Anki or Anki, however you want to say it, which is kind of a flashcard app that's like highly customizable to various use cases. So definitely check those out. They will help you learn a lot of things in a very short amount of time instead of like banging your head against the same material trying to study it less effectively.
So many, there are going to be so many links in this podcast episode description.
Yeah, I'll send you all the links so you don't have to go find them.
Wow, so this has been awesome. I really had a lot of fun. So thank you, Charlene, for taking part.
Yeah, for sure. Thanks for inviting me.
And thank you to all the listeners or viewers. It was a pleasure having you here as well. And I'll see you in the next episode. So bye, everyone.
Bye, everyone.
Thank you for listening to the MLOps podcast. If you enjoyed this episode, please like the video or subscribe. If you have any feedback, leave a comment below. Thanks again for listening and see you next time.